All right.
I'm running on.
April 1, cubic and cube root functions. Today is about their attributes. It's kind of like I emailed you guys. It's gonna be a little fast and furious because it's stuff you kind of already know. All right. Well, I posted on your canvas. Cube function. So I gave you a graph paper if you wanted to draw perfectly. It doesn't have to be perfect. But here's our parent function for cube function. It is y equals x to the third. That's why it's called a cube function. Okay. Yes, you're writing your notes in your notebook. Yes, you have all of page 161 and 162 in your notebook to get her done. Okay. To get her done. You got all that space. We have 3 graphs. We have 3 graphs. That's it. All right. So we have our parent function, y equals x to the third, right? From here, we can identify key points. Our key points are -1, 0, 0, and 1, 1. So if you're trying to graph, that's what you're graphing, okay? So we're gonna create our table. So if you're graphing, you have -1, 0, 0, 1, 1. That is what you're drawing your sketch of. Does it have to be perfect? No, it doesn't. It's a sketch. And as long as you label it as this is my graph, then you're good.
No, I like taking, I know, I just, you don't really do it. I said, oh, I'm gonna take some pictures.
Oh.
You can take my
She's
picture.
taking pic- Look, I did hear that.
Yeah, they're like,
You can take my picture and tell me what this is.
No, that's all right. It just, I just came down here to see now. We're not heard her talking.
oh, I know. My room is really hot, so I don't close my door. Yeah, that's why I don't close my door. If I close the door, it's,
Yeah, I mean, you got those sort of blinds up.
yeah. My makeshift curtains that I'm.
Yeah, I think it's.
What's
some of that out.
Can one page just be graphed?
Yeah, you can do it however you want to do. We're just using pages 1 to 2.
When I got you the chocolate.
We have 4 slides.
No. Here's that.
Yeah, we have 4 slides though.
Cube functions. Is that what you're in solve for cube functions?
We're cube function attributes. We're not solving yet. You're fast forwarding in line. We're just identifying our attributes. All right. Ready? Did we all draw our sketches? I don't want to rush you.
Yeah.
What? How perfect are y'all making it?
Just don't smile for the picture.
No.
She doesn't want me to smile.
She doesn't.
I know what I'm doing.
We'll walk
All right. Yes, she doesn't want you to look at her. All right, your domain. Now that we have it drawn from left to right, what is the function doing? Is there any point where our domain stops? No, it's uninterrupted. So that means it's all real numbers from -infinity to positive infinity. What about our range? From bottom to top, is it interrupted? No. So what does that make it? All real numbers. Okay. Questions so far? Next, we're going to talk about identifying the intercept. You have both pages to utilize and the graph paper that I put on your table.
Okay, don't get on to me. Tell me again.
Cubic function attributes. Cube function attributes. All right, intercept. Where is it? 0, 0. Okay, this is important for a cube function. Okay, the reason why it's important is because it has a special type of symmetry. All right, our symmetry, it's called rotational symmetry. Okay, it's rotational symmetry through the origin or around the origin, but basically whichever word you choose to use. Okay, so the fact that our intercept is at 0, 0 is key to what type of symmetry we have. And again, it's called rotational symmetry around the origin. Okay, how do we feel?
Amazing.
Gabby, why do you write so tiny?
I know what it says.
Oh, okay,
Miss
as long
Jones,
as you know.
Whatever makes your heart happy.
You're the best teacher and that you should get a raise and, you know.
From a video and type it. I was just coming down here
They should
because I
promote
just
you.
thought of her and I was gonna say, what did she
Right.
think?
Ready? Where are we at, guys? Oh, increasing. So Also, when you're describing functions, you're describing intervals of increasing and intervals of decreasing. Because this graph, as we read it from left to right, is there an interval of decrease? No, you're following it along and it's increasing. So this graph only has, the parent function only has an interval of increasing. And when you're describing intervals of increasing or decreasing, you use parentheses only, and where it starts and where it ends. So we start at negative infinity and we end at positive infinity. Okay, so these are our parent function attributes.
Hey,
Nice.
Do they make sense?
Yeah.
in a way.
Do you have questions about them?
No, just
Okay, let me further elaborate on rotational symmetry. Rotational symmetry just basically means that it goes through the origin, and if you were to rotate your paper upside down, your image should look the same.
oh my God.
Okay, that's what the rotational symmetry is telling you. Yes, I mean, we're not perfect computer drawings, but oh, I'm sorry, my. All right. So with that being said, I'm going to show you its inverse function, and the inverse of the cube function. Anyone want to take a stab at it? Is the cube root function. So going based on what we just did, I would like for you to take a moment and write the attributes for the cube root function. So based on what we just did with the cube function, write the attributes for the cube root function. You'll think about it because they look so much different, right?
Did you think it was funny that you told me that?
I thought it was funny.
Thank you. I think it's the truth, and the truth needs to be heard.
All right, so let's check and see how you all did. Hopefully this is the gist of what you got.
I was drawing.
I thought we were.
Yeah, I said draw and write the attributes.
Daniel, it's your fault. Yeah, Daniel distracted me, Miss Jones.
Me too.
Yep, they're the same.
Wait.
Exactly, because what does inverse mean? That means your X and Y values are changing places. But what happened with our X and Y values? They were the same. Their numbers were the same.
Miss Jones, I think next year I should get a graph notebook for math, because this is
do an example. Here's our example graph that we're going to analyze. So, yes. Okay, this is our third and final graph you have to draw. Okay, so example 1, we have find the intercepts, describe the intervals of increase and decrease in max and min. This is a cube function. Okay, this is a cube function. It does not look a whole lot like its parent function, does it? No, not really. Cube functions are one of the, when your polynomial values start getting larger, as they change a lot from their parent function. Now, this is still the same function, it's just that its curves are more defined. It's changing, it got wider. It has intervals of increase and decrease now, right? And so that's what we're going to talk about. This is still a cube function with some very defined points. So the best way to draw a cube function is to identify your intercepts and your points of increase and decrease, okay? Nope, we're going to talk about the attributes and draw it. Ready?
Yeah.
All right, so we're going to go over the intercepts. So step 1 is identifying your intercepts, okay? Where do you cross the X and Y axis? And you can write them as an ordered pair. You can write them as a table. I'm going to do the intercepts on a table. Is that okay? Okay, so intercepts on a table. So I'm starting from left to right. I have an X-intercept here at 1, 2, 3, 4, -4, 0. Do we see that?
Yeah.
I have a another X-intercept here at -1, 0. My Y-intercept is here at 0, -2. And I have another X-intercept here at 2, 0. So I know that these 3 things have to be on my graph that I sketched. Does that make sense?
Mhm.
So these are the 3 key things that have to be on my graph. Agreed? Yes? Okay. Next, in order to sketch a graph or to identify a graph, is you have to know where it's increasing and decreasing, okay? Just like you read a book, we read increasing and decreasing from left to
Left to
right. So from left to right, what is happening? Well, I'm starting over here at -infinity, and I'm going up, 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 up. So that's an increase. So I'm increasing up until this point.
Okay.
This point is roughly at, let's say, -2.7 and +2.7, we'll call it.
Okay.
2.7, 2.8, whatever your heart tells you. So that's a point of increase. Then I keep reading my graph from left to right. And then from here to here, what is it doing? Decreasing. This is decreasing, and it decreases up until here. And this is, looks like,
Go 1.5. No, 0.6.
Oh.
0.7, okay.
I'm just going to stick with 7s for today. I'm feeling it in my spirit. 7 and -2.7. So that's decreasing. And then it does what from here? Increases all the way to what? Infinity. Okay. So when it's saying to describe your intervals of increasing and decreasing, you're looking at the graph and reading it from left to right and saying what happened. So we increase from -infinity. And when you're describing, you're only using your X values because that's your independent variable, right? So we're describing it from -infinity to -2.7. That's one interval of increase. And where's my other interval of increase? Point 0.7 to +infinity, right? So those are my intervals of increasing. Then I have an interval of decrease. And from decreasing, again, you're only using your X values. So from -2.7 to +0.7, what is the graph doing? Decreasing. And that's how you describe the increasing and decreasing when it's not the parent function. Because our parent functions are doing what forever? Increasing, right? However, change happens. Kids act different than their parents. This is an example of when the kids act different. Okay. All right. Next, it says identify your max and min from 1 to 2. When it tells you from 1 to 2, that means that's all you're looking at. So as you can see, I highlighted at x equals 1 and I highlighted at x equals 2. So just looking from between these highlights, what is my max value? My max value is 0, right? That's the highest it goes up to. Remember, we talked about before that values are your y. What is the value? And then our min value would be what? It looks like 2. We're gonna 2.5, negative 2.5. We'll roll with that. Negative 2.5. Because from the interval from 1 to 2 where I highlighted, that's all you're looking at. So from 1 to 2, what is your largest value and what is your smallest value? So my largest value is at 0 and my smallest is at negative 2.5. Okay, terrible?
No.
Do you feel confident in finding intercepts, increasing, decreasing, and max values and min value? All right. Huh? You got one to do on your own. All right, last example, but this time you have to make the graph. So we don't have our handheld calculator, so you do have to use Desmos, but I'll pull the graph up for you. So if I give you the function and there's no graph, you're like, no, miss, I don't have a graph. That's okay. Because what should you do? Use a graphing utensil, a graphing device to create one. So I'll graph it for you up here since we don't have calculators in the class. All right, so here you go. Please analyze. So you're finding intercepts. You're finding points of increase and decrease. And it asks from 0 to 2, what's your max and min? You're going to click here. You got to go to functions and scroll down. And you should see at the very bottom where it has the root with the n. And that allows you to put in whatever root you need to. Okay. So again, it's function and you got to scroll down to number theory, click there, and now that's how you input a 3. What'd you do? Okay, let's see how we did. Show our intercepts are pretty obvious, right? So you have your x-intercept and you have your y-intercept. Okay, on our previous example, it had 3 x-intercepts and 1 y-intercept. So a cube function or a cube root function can have up to 3, right? But does it have to? No, okay. All right, next then we're going to talk about the intervals of increasing or decreasing. Well, what is this graph doing? Is there any point where it decreases? No, so you only had an interval of increase. And that was from negative infinity to positive infinity because it goes forever from left to right. Then it said, where's your max and min? From 0 to 2. So from 0 to 2, so at 0, we're here. And 2, we're here. So our max value is 2, y equals 2. And our min value is 1.26, y equals 1.26. And that concludes our lesson.
Nice.
Doable?
So can I just like glue it like this?